All right, on these two problems, they're wanting you to find the x and y-intercept. Anytime you have to graph, I especially like the y-intercept. I'm always looking for that. So they're just two simple points to be able to find eventually when you're going to need to graph. The y-intercept, this is my favorite point. Okay, I'm always looking for that. Sometimes your graph won't intersect the y-intercept, but if it does, I want to know where. Okay, how do you do that? Well, if you're looking for the y-intercept, just like you always do for any graph, whether it's a straight line, a circle, who cares, you always do the opposite, and you're going to let x be 0. So right here, you're going to plug in 0 for x. If x is 0, let me write in here, plug in 0 for x, you can see you're going to get the square root of 0, which is 0. So you're going to get what? 0 plus 5. So my y-intercept is the point 0, 5. Okay? Now your x-intercept, you're going to do the opposite. You're going to let y be 0. Remember, this is your y value. So basically, I have this. Okay? And then solve for x. Since this is negative, I'm just going to go ahead and move him to the other side so he'll be positive. Okay? To get rid of this, we're going to do the opposite. So we're going to square both sides. So you can see here, x is going to be 25. So that would be my x-intercept. If you want to write it as a point, it would be the point 25, 0. All right? Same thing here. It's wanting you to find both the x and the y-intercept. When you find the y-intercept, you're going to let x be 0, plug in 0. Love it. 0 is so easy to work with. 0 squared is 0. So you're going to get 0 minus 12, which is negative 12. So again, as you write that as an ordered pair, remember you plugged in 0, out pop negative 12, so there's your point. Again, the y-intercept, always want to know your y-intercept. Okay, x-intercept, think opposite. If you're looking for the x, you're going to plug in 0 for y. This value represents your y. So I'm going to plug in 0 for that, and then solve for x. I'm going to move my 12 over. Who cares which one you move over? I always look, hey, if there's a negative one, that's what I'm going to move, just so it'll be positive. When you solve for x, you're going to have to take the square root of both sides, but remember when you take the square root of both sides, you have to do a little plus or minus. So I've got x equals plus or minus the square root of 12. But again, take one step further. You will miss it on Alex. You will miss at least 1 point, half point, depending what it's worth on a test. If there's a perfect square in here, you have to take time to go ahead and reduce it. So think about it. There is a perfect square. You could write this as 4 times 3. The square root of 4 is perfect, so you can pull it out. The square root of 4 is 2, so technically your answer is plus or minus 2 square roots of 3. Telling you there are 2 x-intercepts on that graph. To write it as a point, you can either write it as this. Let's see. You can write 2 square roots of 3, 0. I would probably be lazy and just do my little plus or minus like that. If you want to write it as 2 unique points, that's fine as well. All right, so that's how you do it.